Y vamos a cerrar con el profesor Serkan, que es el subdirector del Australian Centre for Space Engineering Research en la Universidad de New South Wales. Y su presentación es Space Resources Activity in Australia and its Relationship with the Mining Companies. Y esta va a explorar cómo Australia, con su fuerte industria minera, igual como Chile, está integrando capacidades para liderar también en el desarrollo de recursos fuera del planeta. Welcome, Serkan, and the floor is yours. Thanks.
Thank you very much, Carlos. Thanks for the invite. And so it's about 4:15 a.m. in Sydney. So I arrived yesterday. Please excuse if I do any mistakes. I'm struggling a bit to be very awake, but I had maybe 4 or 5 coffees already. And so I know we are pressed with the time, so I will try to be quicker than expected. So what you see here is our CubeSat. So if you can click the video, I don't think I can click the video here. Yeah, yeah, it's working. So this is the simulation of our CubeSat currently in the space, developed by UNSW and our center, AXA. And so a bit of myself, Carlos said a couple of things. I'm a very much mining engineer. All of my degrees are from mining engineer. But I'm work on deputy director of Space Center in UNSW, which I have a couple of hats. I'm also chair of mining engineering at the School of Minerals and Energy Resource Engineering. I'm here in Chile because of also attending Expo Min starting tomorrow. So quickly about our school, we are ranked in the in global ranking number 2 in the world. So number 1 is, I'm not sure Angel is here still, number 1 is Colorado School of Mines, as you may know that. So we are also number 10 in the petroleum engineering, but we provide both undergraduate and postgraduate students about $20 million research income annually, and we got 300 plus students, postgraduate and undergraduate, plus 80 plus PhD students, which is quite a remarkable number for a small school. So Australian Centre for Space Engineering Research, we actually, I'm not going to go through all of it, but we built CubeSats, as I mentioned, as well as we lobbied for establishing the Australian Space Agency, which established in 2018, and also led lobbying of, and also invented off-Earth mining forums, which we started in 2013. Catherine mentioned that there are only 2 key events in space resources. One is in Colorado, other one is in Luxembourg. I would add off-Earth mining forum as well. I believe we are the first group that we established these events. So Angel can correct me if I'm wrong. So as I mentioned, Australian Space Agency is very new, established in 2018. And we are part of the NASA Artemis Accord, also Angel mentioned in his speech. Now we are ready for space. So it's a little bit of fun, but you know, everyone knows how it works boomerang. So we are full on. But also we are known that in 2020, Hayabusa 2 mission completed and landed on Kupupidi in South Australia. So that was on the news as well. So Australia, I want to talk a little bit about capabilities of Australia. Australia most recently established for 2024 and 2025 budget more than $22 billion. I'm talking about Australian dollars, but the billion is too big anyway. There's no need to convert. And future made in Australia. So that's focusing, developing technologies and achieving net zero for the future. So space is actually a big part of it because Australia's space sector is really big, very big, skyrocketing with annual growth of more than 7%. So the industry is really aiming by 2030 to be $12 billion of industry. So they're quite a bit impressive numbers. And in New South Wales government, actually, we are part of in New South Wales government supporting Future Made in Australia as well, with the space capabilities, space engineering capabilities. So looking at sectors in the space industry in our states, space systems, launch and support services, ground systems, space-enabled services and applications, R&D and education training through the universities and research organizations. But I add this last night, actually, because I just learned that from New South Wales government, which is very new. It's just been announced this week. New South Wales Trade Investment Strategy, which not been fully released yet, but MET sector will be, MET means mining, equipment, technology, and services, will be formally recognized as the priority export industry for New South Wales. Within this framework, space mining has emerged as a key area of strategic focus for the New South Wales government's industry development agenda. So I've been told by the New South Wales government to add this, actually very impressive, actually. I just learned last night, as I said. So the National Space Industry Development Hub, actually established in New South Wales government through the Sakada Innovations, will be very important central platform developed in New South Wales industry. So also New South Wales government co-hosting the International Astronautical Congress, ISC 2025. We're expecting 80,000 people to Sydney, arriving Sydney in September, starting in 29 September, which is my birthday actually. So we can celebrate with 80,000 people. So I'll talk about it a bit later on this. So I also wanted to include some of the Australian startups and SMEs in the sector, which is quite impressive. Some of them already been mentioned through Angel and others throughout today's presentation. So Fleet Space is actually quite growing. I mean, in 2013-14, they established like 2 people. Now they got more than 100 people working. Very similar story of iSpace, actually. And Fleet is working on IoT technologies from space, but also performing in mining industry. And Gilmore Space is a launching company in Queensland, and HEO Robotics is actually a spin-off from UNSW PhD students. They studied in asteroid mining and established this company, very rapidly growing. They got more than 100 people as well. And SPE, Edge Computing Hardware for Space. Extraterrestrial Power is also a spin-off from UNSW, working on solar power systems. Sabre Astronics, which is space mining mission design, very similar to ASRIC on incubators. And Fugro is actually an exploration company based in Western Australia, but they're working on space resource exploration as well. They established SPARC, most recently, Australian Space Automation and Robotics Control Complex in Perth. And Interlune is an American company, but also operating in Australia, working on extracting space resources from the moon. And extracting space resources, Queensland-based, and I think South Australia, could be South Australia as well, focusing on asteroid mining. So these are the companies. And on the right-hand side, I put other organizations. So EROS, which is, I can't see this. So which is Australian Resource, I can't read it, but EROS is actually a remote operations center, both operating for space and Earth industries, and it's an NGO, and UNSW is a partner with EROS. Adelaide University, as you may see the difference, University of South Australia and University of Adelaide now merge under the Adelaide University. There's only one university now in South Australia. So they have Andy Thomas Center for Space Resources, and they're providing a space resources training program. It's not accredited, it's not a master program yet. So CSIRO's ISRU facility working on lunar test beds and rapidly growing in that area. And QUT is actually Queensland University of Technology. They got recently a new space lab and lunar bed, which they collaborate with UNSW. I'll talk about this a little bit later. So these are the all major capabilities of current Australian capabilities in space resources. In addition to that, Australian government created some more initiatives about worth of $9 million on 12 projects. So one of them, focusing on Moon to Mars initiative for Artemis program. So Valiant Space, a Queensland-based company, about $1 million developing non-toxic propulsion system. And Next Aero, Victoria-based, about $1 million funding for design and manufacture and validating cryogenic rocket propellants. HUA, as I said, UNSW background company, $700,000 to develop advanced cameras for imaging satellites. And Newman Space is South Australian company. They got about $1 million for developing spacecraft electric propulsion manufacturing technologies. In addition to that, and based on the Artemis program, to support NASA's Artemis program, Australian government developed Trailblazer program in 2021. So they initiated stage 1 projects, which went to EROS, about $4 million to develop a rover system, and also Zangold, about $2 million. But that was the first stage, and the second stage been announced recently, which is about $42 million on, I can't see it here anyway. So developing this rover. Rover is the official name of the Australian rover, will be landed on the moon. That's the most recent update on that. And then a little bit of UNSW marketing and what we're doing in this area. So as I said, we established Off-Earth Mining Forum in 2013. And we're not running this every year. We're trying to do it in every 2 years. So we run 6 of them so far, and the 7th one will be on 25th and 26th September this year. Just before the ISE, we want to use the opportunity. People will come to Sydney already, and they can attend Off-Earth Mining Forum. Off-Earth Mining Forum only works with the invitation. So if you are interested, I know iSpace will be coming, Epiroc will be coming. And if you are interested to present, please let me know as soon as possible, because we're finalizing the program soon. So UNSW also developed 2 sets of software packages for NASA. First one was the water extraction Mars mining model, basically for linear programming for equipment selectivity. We developed together with Jet Propulsion Laboratory. And then second software was mining optimization and Mars mining operation optimizer. We developed this part of the SBIR US government funding together with Virginia Tech and Kennedy Space Center. They're all active software packages used by NASA right now. So what we're doing in UNSW, our ultimate aim to reduce the risk perceived by a potential investor in space resources venture. That's what our focus. So we develop a wild project for the moon resource engineering activities, but very much collaborative research. If you look at very multidisciplinary in engineering faculty, we collaborate almost every engineering discipline, as well as interfaculty in engineering science, business law, arts and human and built environment faculties in UNSW. And we collaborate with iSpace. We got a partnership agreement. We got partnership agreement with Epiroc, Interlearn, Fleet Space, and EROS. Also international partners, NASA Jet Propulsion Laboratory, Caltech, European Space Agency, Korean Institute of Civil and Tunneling, KICT, and the Japanese Geological Survey. So we are currently very international, and we keep adding the new partners on this. So we do a lot of collaboration, as I said. I'm not going to go through all of it. So we've been part of both NASA and European Space Agency projects, and we've been part of the advisor as an advisor of LORS 101 developed by Carlos in the past. And so the facilities, so these facilities are quite new, and so our focus is developing space supporting laboratories. On the right-hand side, you see the spacecraft innovation laboratories, more in the electrical engineering school as part of AXA, but also we're focusing most recently in extreme environment laboratories. So rock testing in environmental chamber, plus minus 200 degrees, we can test rocks, which is unique. We got only in our university, we develop ourselves this equipment, and micro CT, which exists for many universities, but virtual reality and hologram specifically used for the space activities, we have this only in our university. And we're working on the processing and also thermal vacuum chamber, but also dirty vacuum chamber. Catherine was talking about they will get it in ESRIC soon. We have it already, and this is the only equipment in Southern Hemisphere, as far as I know, and we will also have Munyar. So we are opening these facilities this month, actually. So we got also UNSW's vertically integrated projects. So all the engineering first and second year students working VIP projects. We got 2 projects under this scheme, MINEX and Off-World Robotics. So imagine that we got about 1,000 first year students in engineering. So they're working in those 2 projects in group of 8. So it's quite a bit capacity. They develop ideas, and then they won first time in 3rd space in Over the Dusty Moon Challenge, Colorado School of Mines. And then year after, they become number 2. So we are quite proud of it. And then I developed Space Resources Engineering course. Carlos taught last year one part, and hopefully we'll do it next year as well. And this is not a program yet, but this is the course only in our master program. So I established part of International Society of Rock Mechanics and Rock Engineering. I established Commission on Planetary Rock Mechanics. As you see, our group's quite multidisciplinary and international, and we trying to create a new sub-discipline under the rock mechanics, because we know that planets, rocks being formed different than Earth and very extreme environments. So we're trying to understand how these rocks will behave, because it's very important for materials handling and mining activities, for space resources engineering activities. So PhDs are very important, big part of our work. So we got about 11 students, but 7 of them, I can say the 7th one graduate because just submitted. And so as far as I know, Jessica is world's first PhD graduated from mining engineering school in space resources topic. So she's currently working in New Zealand Space Agency as a space policy developer, senior space policy developer. We are all proud of our students, and we publish about more than 40 papers. So I put some of them here. So we're working in very different range of topics, as you see from the PhD topics. So we're working on the mining systems, extraction technologies, sustainability, and economics, and rover design, architectural design. So all these. So some of these students already established their spin-off companies and rapidly growing. So that was the current status of what's happening in Australia. I want to cover right now how the mining industry takes into this. So I'm not going to cover that. Angel and all others already talk about why we need, what's the motivation. And so the question is, who is going to do it? But Carlos already talked about a little bit of history, but everyone is expecting space resources activities will be done by the major agencies, as all you may expect. But to me, if you look at the first flying man, researcher, I would say, was in Hazarfen Çelebi in Istanbul in 1632, which he died in the, in the tests. And then Montgolfier brothers in 1783, first hot air balloon carried humans. And then, of course, Wright brothers. And none of them funded by governments. None of them were government employees. So I believe we should consider these private entities as we discussed, and some of the examples here, off-world and iSpace and others. So I want to really quickly go through the space industry's major achievements. Space exploration, satellites, spin-off technologies, Earth observation and climate science, international cooperation, inspiration, and developing space economy. These are the major industries, space industry's major achievements. If you look at what are the major factors dominating the space economy today, looking at all these telecoms, GPS, Earth observations, and also equipment like space vehicle, ground and space stations, and all the receivers and etc., as well as the agencies' development and satellites. These are the major factors dominating the space economy today. But spin-offs are very important too. Even the seats we're using currently in our cars, being first, it's a spin-off from the space seats, actually, space vehicle seats. So, I mean, I'm not going to name all of them, but really many spin-offs coming from the space industry in our daily life, we use in our daily life. But the future for space resources, I mean, previous speakers already covered, but I think the colonization and then crewed operations and reducing investors' risks and creating markets, perhaps first tourism and then mining, or first mining and then tourism, or together. And then space debris mitigation, zero waste operations, and then space-based energy systems, probably the upcoming future activities for the space resources industry. And then legal framework, ethical standards, Carlos already talked about. So if you look at the mining industry, so achievements, so we are we providing the raw materials for almost every industry, and then we develop the metallurgy and processing activities, and then we are the main reason of industrial revolution. So we name first, second, and third. I'm not sure we are in the industry 4.0 or not yet, because we will know that in 20, 30 years later. But energy production, as well as mining industry, develop first risk management practices, which every other industry is using right now. Looking at the major factors dominating the mining economy today, the commodity market, of course, supply, demand, and price changes and cost activities. Also, as Jim mentioned about environmental and social and governance, which is sort of new terminology for mining industry, replacing sustainability words, sustainable mining practices, which meaningful. All development of regulations for environment and sustainability, all infrastructure, risk management, and of course the skills. And also all these MATS, mining equipment technology services, in really supporting most of the mining activities. I mean, Epiroc, one of them, iSpace, and also Carlos also mentioned that. And spin-off from mining industry is actually zero, because miners like to be first to be second. So you can't name, I'm teaching technology management course, which Carlos sit down in years ago on that course in master. I can't find any mining innovation done, which we are currently using in other industries. So we don't have any spin-offs. That tells us something about the industry. So the industry's future of mining industry is mining industry's future, I guess, three things. Zero human entry. Zero entry mining. Jim already talked about that. Zero waste mining. Jim also talked about that. And zero emission. He didn't mention specifically, but I think is one of the outcome. So we need to issue these three zeros for the future. because it's very important. I'll come back to you later very quickly. So space and mining, superficially similar. The commonalities, they're both multinational. They have long life of operations. We are both operating in remote areas, in extreme environments, as well as with extreme risks and high cost and financing projects we have. The challenges, I'm not going to repeat, everyone already mentioned, and mostly Carlos talked about it. So all of these challenges is quite important. So Jim mentioned about these autonomy, automation, how much human intervention required, involvement required, which we couldn't really talk. But also managing the technology is a big challenge for both industries. And regulatory already been discussed with by Carlos. So now very quickly, how the technology transfer can be achieved from space to mining. What are the drivers? What are the impediments? So the drivers from space to mining, spin-off success, as mentioned before. So social acceptance. Jim mentioned how bad in social acceptance in mining, so we can learn from space industry. And which reputation, experience in autonomous systems and robotics, knowledge and of navigation systems and communications, systems engineering approach. Mining industries right now is taking this from space industry, and potential to eliminate Earth's resource scarcity, and being good role model for international partnership and collaboration. Space is excellent on that. Failure is not an option approach, is very actively working in space, which mining we more try and error approach we have. And impediments of transfer from space to mining, lack of financial motivation, not fully commercialized industry yet, and high risks, skills shortage, lack of regulations, higher uncertainty, lack of accepted resource classification, lack of existing activities. As I mentioned, miners like to be first to be second, so mining industry is waiting someone else to start the mining activities in space. I don't know how it's going to happen. I think we're going to discuss this in panel soon. And then how we can transfer technology from mining to space. So the drivers are experience in robust and efficient equipment, experience in remote operations, expertise in resource extraction and processing. Mining industry knows this very well. Performing projects with high capital expenditures and high investment risks. Revenue generation expertise. Space was not focusing revenue generation. I mean, space exploration, all about going there, mostly for science purpose. And safety culture and risk management, as I mentioned, developed in mining industry, developed for mining industry. Being a highly regulated industry, that may help to implement new technologies, transfer. Impediments, big market uncertainty in space resources, so prices versus cost. I mean, Jim already talked about it a bit, and also Marshall. And lack of innovation culture in mining, as I mentioned, no spin-offs. Size does matter. Big, not always good and better. That's, I think it's key. So mining industry's new motto, I guess, for me, small is the new big. As Jim mentioned about selective mining, what I say precision mining. Reputation of mining is not good. And I think one of the big part is we don't have next giant leap for mining industry. And conclusions, I will pose some of questions, and I don't have really the answers. I got ideas. What is the mining industry's version of next giant leap? Is it critical minerals? I don't know. We can discuss that. To me, when the entire industry unites around a shared goal, it creates alignment, and alignment fuels collective action. Net zero targets could be the answer for it. Can mining industry deliver for the future? You saw the nice graphs from Jim, right? So it's actually inconvenient truth. No, I agree with Jim. not with mining, with this performance of mining, we can't deliver for the future. Because according to International Energy Agency, thanks to Jim to highlight all of these graphs, which I didn't have time to put together for this presentation, we need to mine 6 times more minerals to achieve 2050 targets. That's why we can't deliver. We gotta do change, as also Jim mentioned. Then what the mining industry's big mission. So I'm gonna remind you again, these 3 zeros. 0 waste, 0 emissions, 0 human entry. Chile's mines are famous, right? But not only Chile's on tailing dams we create. I took an amazing photo from the plane landing to Santiago. I believe, I'm not gonna name the company, but you may know that. Also, I know that one of the tailings dam size is bigger than Sydney in Chile. That's inconvenient truth. That's amazing waste we create. And also, all these processing activities, we got value from 1 gram in 1 ton. If you tell this to non-mining person, it's very scary. I said this to one of the ministers in Australia. He's shocked, 1 gram in 1 ton. So Australian chief scientist Katie Foley says that this needs to change. So final conclusion, space mining, a mining industry is really not interested anything about space mining. They only interested technology transfer. Carlos can tell Rio Tinto was the first talking about this. Now they don't have an interest. Now BHP, Think and Act Differently Group, and Epiroc, as you heard from iSpace as well as Carlos. So they only interested on technology transfer. That's the truth. So we need to work on that. So Australia is very much ideal partner for space resources. Why? Because the world's largest mining companies operating in advanced mines, we know how to work in extreme environments. World's top universities in high caliber researchers and facilities. I mean, UNSW is one of them, as I mentioned. And then I like this quote from Anat Singh. She wrote, she's an anthropologist actually. She's talking about how human evolution impacting the industries in her book. It's called Not Yet. So space is not yet capitalist. Space is not yet colonized. Space is not yet mined. Space is not yet fully legally, technically, and economically governed. So stay tuned. I think we gotta work all together. And finally, Carlos, I guess, mentioned about Harrison Schmitt. Harrison Schmitt, Apollo 17 astronaut, is the only scientist landed on the moon. All right? All the others were pilot. And he is geologist and he's still alive, and he sent me this picture to show what you're seeing here, the geology hammer, he threw on the moon's surface and took the photo. It is real photo. He sent himself. That's a hammer. It's a geology hammer. Yeah, he threw his hammer on the space and took the photo in Apollo 17. Thank you very much for your attention.